This video is entitled Chapter 1, What is a Model and Why Model Data? It goes along with the book Introduction to Database Systems Modeling Administration, and I'm Dr. Reneau, and I'll be taking you through this presentation. So the first question is, what is a model? I want to define a model as a representation of a much larger real world kind of problem. It's a description or an analogy. You can think of a picture or a diagram as a model of something much more complex. Models help us human beings visualize. You know, we've been creating models since really the beginning of time. The picture here, picture over there, is of a cave dwelling from several thousand years ago. We've been doing it forever, modeling. And as we go into data, data gets so complex that the human brain just can't comprehend some of these things. And so we create models to help us understand what we're doing. Models take lots of forms: drawings, sketches, blueprints from engineers, prototypes for a specific purpose. For instance, let's think about a model for an airplane. A paper airplane is a really good model of an airplane because it flies, as long as you push it hard enough. You could also build a plastic model of an airplane that looks a lot more realistic, but it doesn't fly. Airplane manufacturers will build large models of an airplane to put them in wind tunnels to actually see how they behave before they start spending millions of dollars to build the first prototype. Each model has a fidelity. We talk about a fidelity and how close it is to the real thing. A diagram of a building is a very low fidelity, or a sketch of a building would be a very low fidelity model, but a blueprint with measurements and with wiring plans and with plumbing plans and all of that starts to become a lot higher fidelity of a model. It's the same in data, and we'll move through several different fidelities of models as we go through data modeling. Another really important definition, and three words that we really need to know and need to use correctly in all of our systems and our design and our data modeling and our databases, are the words data, information, and knowledge. Data isn't a robot found on Star Trek Next Generation. Well, it is, but data are the factual little bits of information. They're the raw facts collected in a business. Think about the details that a point of sale terminal collects. Every time it goes beep, it records the barcode, the date, the time, the terminal, the order number, the lots of things are these raw bits of data. Data, when it's saved into a database, is voluminous. It's huge. It can be extremely complex, and there can be so much of it. No, again, human can really understand it. And what our job will be later is to take this data and convert it into information. We distill the data into meaning. We put it into reports and dashboards and pictures and graphics and things. We summarize the data so that we can really understand what the data is. And then lastly, knowledge is when the information is brought into the human brain. It's brought into our consciousness, and we can internalize that information, the data distilled into information and then internalized into the human brain, and we can start doing action upon it and really make business decisions based upon the information that was based on the data. So we've defined data and we've defined a model. So let's now define a data model. A data model describes data. It doesn't contain the actual values of data. For instance, if I were modeling um, people, or if I were modeling actors in a play, the name of the actor, the specific name of the actor, like well, I'm just trying to Sandra Bullock, the actress, the role that they're in, the specific name of the role that they're in, their birthday, and all of that are things we're going to model, but we don't model the actual detailed data. We model the names of the attributes. We model the names of the of the various bits of data we're collecting, and we say it describes data. A data model is usually done graphically because when we have lots of different sources of data and lots of tables of data, and we'll learn what those are later, it really becomes complex and difficult to see without it being a picture that we can wrap our heads around. A data model has to be concise because if it's difficult to understand or has too much stuff in it, it just won't be useful. It'll be more like reading programming code instead of a model. Think of that model of the animal painted on the cave wall. It described an animal very well, and it had enough detail to communicate to the stakeholders what was important without overcomplicating it. That's the thing. A data model really has to facilitate communication between everybody. So we can get the stakeholders, shareholders, the people that are involved, the end users, maybe, to help us look at our data models and understand that we understand their problem. That helps us to communicate with them and them with us. So it will help us to communicate between the shareholders, stakeholders, and the technical people, but it'll also help us to communicate from technical person to technical person, as one person might have created the database data model and another person sometime years later will have to understand what the data means and how it's organized, and will turn to that model as a concise, simple, graphical, understandable way to see the data. Data models are not a model like the cave painting that was painted once and not painted again, was never changed. A data model has a life cycle. A data model is incremental. It will usually start with a very simple understanding of the business problem or the data we're collecting, and it will grow over time and add detail as we learn more, as we figure out more, as we as we again learn more about the problem. It's iterative. It's a living document. The data model isn't do it once, print it out, hang it on the wall, and we're all going to look at it for years to come, because the business rules change, legislation changes, the customer's needs change, the client's needs change, things change. And it will grow and develop as we continue to move forward. And again, it's collaborative. It's to open that communication with all of the stakeholders, with the programmers, the analysts, the database engineers, the end users, and lots of others will potentially go and be taken through this model to really gain an understanding of the problem. So a data model has a very clear life cycle. It's incremental, it's always changing, it's iterative, and it's collaborative. So, like with other models, in a data model, we have fidelities. And there are four fidelities I'm going to cover in this video presentation. The first is called the enterprise data model, and it's really a model of models because each of the different parts of the enterprise will have a data model that go along with that part of the enterprise, and we'll see how those data models then interact with each other on a enterprise wide kind of idea, on an enterprise wide understanding. The conceptual model is the initial understanding of how the entities and relationships within our system are going to connect. And we'll talk about what an entity and a relationship is in a future slide, but I need you to think about a conceptual model. It's a rough sketch. It's not necessarily a rough sketch, but it's a sketch. If we were going to build a house, the conceptual model of the house would be maybe a really rough diagram of the house. Maybe is it a ranch? Is it a two-story? Just those kind of general rough ideas of what the model is, of what the data model is going to look like. The next two fidelities, which each get into more and more detail as we go through the different layers of fidelity, are the logical data model, which includes a complete understanding of the entities, the relationships, and the attributes of the entities. Like with the actor I mentioned earlier, their name, their birthday, their role, all of those kinds of things are attributes within the entity of the actor. Then the physical data model is how the data is actually stored in our database system. It again adds additional data for data types, keys, and other data types, keys, indexes, and lots of additional stuff that we'll get into later in this book. But just think and remember that we go from conceptual model, enterprise model, to conceptual model, to logical model, to physical model as models increase in their complexity and fidelity and closeness to the real data. This concludes our first video in this series. I'd like to say thank you for watching, and I hope this was helpful in your understanding of what is a model and why we data model.